Welcome. This video is on solving radical equations. Here are some examples of some radical equations. The square root of 2x minus 5 equals 7. The cube root of 3x plus 4 equals x minus 2. This last one has a square root on both sides of the equal sign. Square root of x minus 3 equals the square root of 2x minus 1 plus 4. That last one's a little bit of a challenge to solve, but it'll be fine. Okay, so we're going to use this rule for exponents, this property. If a equals b, then a to the power n equals b to the power n. You've heard that saying, whatever you do to one side, you have to do to the other. Well, that's what this is. If you raise one side to the nth power, then you got to raise the other side to the nth power. So if you square one side, you got to square the other side. If you cube one side, you got to cube the other. Okay, so utilizing this property, what it does is it cancels out the radical. That's our goal here. We want to get rid of the radical sign. By using this property to solve equations with radicals, it will be necessary to perform the check to verify the solution. So I know doing a check is kind of a pain in the butt. I don't like to do it either all the time. Maybe once in a while just to make sure, especially on a test, if I have the right answer, because we make mistakes. But here's the issue. This process will produce answers which do not satisfy the original equation. So you can do everything correctly, and it may give you an answer that doesn't work. Okay, it's called an extraneous solution. I'll write that down a little bit. Anyway, so the check is necessary. Normally I would tell my class, like, if you want to do a check, that's fine. If not, no problem. Here you have to. Okay, so let's talk about when a square root is squared. Square root of 5 squared, or square root of 11 squared, or square root of x squared. Each of them mean you multiply it by itself, and the result is the radicand. It's the number inside the square root symbol. So square root 5 times square root 5 is square root of 25, which is 5. Here's a few more. Square root of 1,261 squared. Do I actually want to multiply 1,261 times another 1,261? Or can I just use a shortcut that the answer is going to be what's inside the radical sign, which is called the radicand? Yeah, definitely. So you could see that the square cancels out the square root. It undoes it. And all we're left with is what's inside the radical sign. Okay, so that's what this note here says. Observe the result of the square of a square root equals the radicand. It's not even necessary to perform the multiplication. The square cancels out the square root. Okay, here's our procedure for solving equations involving radicals. Step 1. Isolate a radical expression on one side of the equation. So get a radical by itself. So suppose we have this equation, square root of x plus 3 minus 4 equals 0. To isolate the radical on the left-hand side, you would add 4 to both sides. Move that 4 over to the right-hand side. Okay, then step 2. Then we're going to use a property. If a equals b, then a to the n equals b to the n. If the radical is a square root, square both sides. If it's a cube root, cube both sides. If it's a fourth root, raise each side to the fourth power. If it's a fifth root, same thing. Raise each side to the fifth power. In general, if it's an nth root, raise each side to the nth power. Now we're going to solve the equation, and that gives us, we'll call them preliminary solutions. We have to check these solutions. If it satisfies the original equation, then that's an answer. If it doesn't, then it's not an answer. So definitely this step is necessary. If the solution checks, then it is a solution to the given equation. If it's not a solution, if it doesn't check, then you just cross it out and you're done with it. If that's the only answer you have and it doesn't work, then you're going to write no solution. If you have two answers and one of them doesn't check, then the remaining solution is your answer. Okay, here's our first problem. Well, we know what the first step is, right? We're going to isolate the radical on the left-hand side. So add 4 to both sides. On the left-hand side, you're going to get the square root of x plus 3, and on the right-hand side, just 4. So that's our first step, is to make sure we have a radical on one side by itself. Now we're going to square both sides. So squaring both sides, the square will cancel out the square root. On the right-hand side, we have to square the number. And now we solve this equation. It's not complicated. All you need to do is subtract 3 on both sides. And we get x equals 13. Now our job is to check that answer into our original equation. So plug in 13 into the original problem wherever you see an x. Let's see, 13 plus 3 is 16. Square root of 16 is 4. 4 minus 4 is 0. Yep, it checks out. So 13 is our answer. Okay, this one's very similar. Just that our answer is a little bit different this time. All right, what's our first step? Isolate the radical. Subtract 6 on both sides. Now we have the square root of 5x plus 1 equals negative 6. Can we have the square root equaling a negative number? No, right? The square root is always equal to a positive number. So right there we could stop. You could do some work and get an answer. If you square both sides, you would get an answer for x. But then when you plug it in, it won't work. I'm not going to show that, but you could. So I'm just going to say that whenever you have a square root and it equals a negative number, we just stop because it's not possible. So you can write there's no solution, or you can use that symbol of 0 with a slash through it. That means no solution. Okay, so it's a little bit more complicated. The square root is already isolated on the left-hand side. So we're going to square both sides to cancel out the square root. On the left-hand side, we'll end up with just 2x minus 4, because again, the square cancels out the square root. On the right-hand side, it's x minus 2 squared, so we're going to have to write that out twice, because that's what it means. X minus 2 squared means x minus 2 times another x minus 2. And now we're going to solve that equation. So FOIL on the right-hand side. because we have an x squared, now we need to get 0 on one side. So I would choose to get 0 on the left-hand side. It's a positive 2x, so subtract the 2x, and then it's a negative 4, so add 4. Do the opposite of those two terms on each side. So that gives us 0 equals x squared minus 6x plus 8. Of course, now we factor, right? We're really good at our factoring now after the last chapter. That was not too bad. What multiplies to be 8 and adds to be negative 6? That would be 4 and 2, both negative. So that's x minus 2 times x minus 4. I didn't show the grouping. If you want to show the grouping, you can. Set each of those factors equal to 0. So we have x minus 2 equals 0 and x minus 4 equals 0. And now solve each equation. They're not hard to solve. Add 2 to both sides on the first one. Add 4 to both sides on the second one. So now we have two answers, 2 and 4. Now we need to do a check. Both of them might work. Maybe only one of them works. Sometimes neither of them work, even though all your steps are correct. Usually though, when you have two answers, one of them should work. That's been my experience. Okay, let's start with the first one. Here's the check for x equals 2. I didn't do a step-by-step. There it is. Again, replace x equals 2 into the original problem. And if you get the same result on both sides of the equals, then it works. So x equals 2 works. Now we'll do x equals 4. So again, plug in x equals 4 into the original problem. And that one works too. Of course, I'm probably going too fast, so make sure you pause the video and work that out. I just kind of put it up there. Alright, so we have two answers because they both work. So we could put them in braces. Braces means that the answers are those numbers. We don't want to use parentheses or brackets. Parentheses and brackets are used for intervals, and it's not between 2 and 4, it's just specifically 2 and 4, therefore we use braces. Okay, here's our next problem. Now, we would like to isolate the radical on the left-hand side. On the left-hand side is 2 square root x. The only way we could isolate the square root x on the left-hand side is to divide by 2. That's legal, we could do it, but then we have to divide by 2 on the right-hand side. That would give us x minus 3 all over 2 on the right-hand side. That's a rational expression. Then we would have to square it. It's going to get a little bit messy if we do that. So we're not going to get rid of the 2 on the left-hand side, although you could. If for some reason on the right-hand side it was a number like 6, just 6, then I would divide by 2, definitely. Okay, so let's square both sides. Okay, now when you square both sides, the square will cancel out the square root. But the 2 in front has to get squared first. So you square the 2 in front. What is 2 squared? Right, that's 4. And then the square will cancel out the square root. So it's going to be 4 times x. And on the right-hand side, we have to write it out twice, and we're going to FOIL just like we did in the last problem. Okay, so on the right side, it's x squared minus 6x plus 9. We have a 4x on the left-hand side. We need to get a 0. Anytime you see an x squared, that means you got to get 0 on one side. Subtract 4x on both sides. And now factor. Usually the factoring in these problems isn't too complicated. products of 9 are 9 and 1 and 3 and 3. We want the numbers to add to equal 10, so that will be 9 and 1, and they will both be negative. So separate that into two equations, and then on the first equation add 9 to both sides, second equation add 1 to both sides. So we have two answers, 9 and 1. Now we need to do the check. So plug in 9, see if it works, and then plug in 1 and see if it works. So here's the check for 9. Remember to put the 9 into the original equation. Square root of 9 is 3, 2 times 3 is 6, and 9 minus 3 on the right hand side is 6, so we got 6 equals 6. Perfect, 9 works. Now let's plug in 1. Square root of 1 is 1, 2 times 1 is 2. Well, on the right hand side, 1 minus 3 is negative 2. 2 does not equal negative 2. So 1 does not work. So when you write your answer, do not put 1 for an answer. You're only going to put 9 for an answer. So do you see what I mean about that this could give us answers that do not work? Here's a little note. This procedure of raising both sides to a power may give solutions which do not satisfy the original equation. These solutions are called extraneous solutions. Okay. Okay, this one's a little bit more complicated. You can see why. There are square roots on both sides. Now, we want to isolate the square root. And we do have the square root isolated. On the left-hand side, it's a square root of x minus 2. Now, just kind of a warning, some problems will have two radicals on one side. In that case, you're going to have to move one of the radicals to the other side to get a radical by itself. Okay, so we're going to square both sides. On the left-hand side, the square will cancel out the square root. On the right-hand side, because there's a minus sign in the middle, you're going to have to write it out twice and then FOIL. Okay, so now when you FOIL on the right-hand side, it's 5 times 5, which is 25, and then 5 times negative square root x plus 3, the outers, that'll be negative 5 square root x plus 3. You do the inners, negative square root x plus 3 times 5, that'll be another negative 5 square root x plus 3. And in the last terms, negative square root x plus 3 times another negative square root x plus 3. Negative times a negative is a positive, so it will be positive. And then whenever you multiply something by itself, a square root by itself, the answer is just the radicand without the square root. So this is what we have. X minus 2 equals 25 minus 5 square root x plus 3 minus another 5 square root x plus 3 plus x plus 3. We still have square roots. We're going to add like terms, and then we're going to try to get that square root by itself. Okay, so one of the things we could do is add the 25 and 3 on the right hand side. That's a 28. The two square root terms, negative 5 square root x plus 3 minus 5 square root x plus 3 is negative 10 square root x plus 3. And then we have an x on both sides. We could subtract the x on each side to get rid of it. So if you minus the x that's next to the 3, minus x there, and then minus x on the left-hand side, the x's will cancel. Hopefully everybody's doing okay. So we have negative 2 equals 28 minus 10 square root x plus 3. Now we can't subtract 10 from 28 because the 10 is attached to the square root x plus 3. We could subtract the 28 on both sides because we're trying to isolate the radical again. So subtract 28 on both sides, and that'll give you negative 30 equals negative 10 square root x plus 3. Now we could square both sides from here, or we could get rid of the 10 on the right-hand side. Because 10 goes into 30, I would suggest we do that. Divide both sides by negative 10. And again, that's only because negative 10 goes into negative 30 evenly. If on the left-hand side it was an x minus 4, then I would not say divide both sides by negative 10, because then we would get a fraction with a variable on the left-hand side. Okay, so let's divide by negative 10. That gives us 3 equals the square root of x plus 3. Now we're going to square both sides a second time. So this is how these problems turn out. When you have a radical on both sides, you end up having to square both sides twice. Okay, on the left-hand side, this is not too bad because it's just a 3. 3 squared is 9. Again, if it was like x minus 3, then you have to write out twice and FOIL, blah, 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 right? And on the right-hand side, the square cancels out the square root. Okay, subtract 3 on both sides, and we get x equals 6. I know it's a lot of work. It might not even be the answer, right? It might be no solution. We have to do the check. So let's plug 6 back in. I know sometimes people get a little like, what the heck? I did all that work and the answer is no solution. But that's math. Okay, plug in 6. Square root of 6 minus 2, that's 4. And the square root of 4 is 2, so you get a 2 on the left-hand side. On the right-hand side, plug in the 6. 6 plus 3 is 9. Square root of 9 is 3. 5 minus 3 is 2. It works. We feel good about it. You could box your 6, put it in braces, and we're done with this example. All right, we're going to talk about cube roots. We said it earlier that when you cube a cube root, you're going to lose a radical. Well, maybe I didn't say that. When you cube a cube root, if you have 3 of that same factor, it comes out to just be the radical. So you can see some examples. Cube root of 2 cubed, there's 3 of them. That gives you cube root of 8, which is 2. And the same thing goes for the cube root of 5 cubed, or the cube root of x cubed. Again, if we wanted to do cube root of 1261 cubed, you can multiply it, but it's just going to be 1261. Okay, so again, when you cube a cube root, it cancels out the cube root. Raising an nth root to the nth power will cancel out the radical. So we're only going to do cube roots and square roots in this video in the homework that I have. But if we had the 5th root of something, then you would raise the radical to the 5th power. Or if you had a 6th root, then you would raise it to the 6th power. Okay, here's our last example, just about done. This one has a cube root. It's already isolated, so we don't have to isolate it. What are we going to do? Yes, we're going to cube both sides to cancel out the cube root. So on the left-hand side, the cube cancels out the cube root, and we're only left with the radicand, the number inside the radical. On the right-hand side, we have to raise 2 to the third power, which is 8. Not too bad. Okay, now we need to get 0 on both sides, so subtract 8 on both sides because we're going to solve the equation. Again, we need a factor. I'm not going to show how to work for the factoring, but you know how to factor trinomials. You're a factoring machine by now. 2 times negative 12 is negative 24. 3 and 8, right? So that gives us 2x plus 3 times x minus 4. We have two answers. Negative 3 halves and positive 4. We have to check our answers. To be honest, with cube roots, we don't really have too many issues that I'm aware of, but we should do the checking anyways just to be sure. Okay, so let's check the 4 first. That's the easy one. It's not a fraction. And that one works out just fine. And then check the negative 3 halves here. Again, I just put the whole work right there. I didn't go through it step by step. You might want to pause the video and go through each step. So replacing the x with negative 3 halves, you got to square it. That gives you the 9/4. And then when you multiply it by 5, put a 1 underneath the 5 and then multiply straight across. That's how we get 15/2. And then we have 2 times 9/4. You could reduce the 2 and 4. That's how you get the 2 on the bottom, 9/2. So you have 9/2 plus 15/2. And then to get common denominators, change the 4 from 4/1 to 8/2 by multiplying the top and bottom by 2. Now all the denominators are the same, so we could add all the numerators. 9 plus 15 is 24. 24 minus 8 is 16. So that's 16/2. 16/2 is the cube root of 8, and the cube root of 8 is 2. So that one works out too. So we do have two answers, negative 3 halves and 4. Okay, it wasn't too bad, not too long of a video, but the problems can get a little tough. So I'll see you here for the next video. Have a good one.